Hello everyone, I'm Doria. Welcome to today's openEuler mini course. In this course, I will talk about openEuler's Livepatch, a kind of kernel hot patch for the openEuler OS. I'll introduce the basic content of a Livepatch, describe how it works, and describe how to use or build it. Hope you find this course both useful and interesting. First of all, what is a kernel hot patch? A kernel hot patch dynamically fixes the kernel functions without restarting the system or rebooting the kernel. Using a hot patch, system administrators can fix kernel bugs or security vulnerabilities conveniently, minimizing system downtime and increasing availability. They can also use hot patches for debugging and testing during development. Kernel hot patches are widely used by many OS and are popular for critical systems, where it's difficult to have downtime for patching. An example of a hot patch is a Linux community implementing patches using the ftrace tool with jump instructions that attach a fixed function to the original function. In this way, when the buggy function is called, it jumps to the ftrace caller. Then in the ftrace handler, by changing the instruction pointer to the fixed function, the patch is installed successfully. openEuler's Livepatch implements fixes in a different way, without the ftrace tool. In openEuler's Livepatch, the jump instruction attaches a new function directly to the original one. This is much faster. In addition, compared with the Linux community solution, it supports more architectures, including x86, ARM64, ARM32, PPC64, and PPC32, and delivers better performance. But it doesn't support ftrace and suspend services during Livepatch installation. Livepatch is designed to be robust and secure, able to patch any type of software bug. It is intended to be used as an alternative to rebooting or suspending the system to apply patches, and can be applied to running systems in a matter of seconds. Let's see the overall framework of a Livepatch, which includes three main parts: the kpatch tool, the patch file, and the kernel. When installing a patch file, first prepare the patch against the kernel tree, configuration file, VM Linux file, and source code for kpatch, which then build the Livepatch. Next, after the KO binary file is built, this file is inserted into the kernel for initialization and processing. Last, a jump instruction is added to the old function to link it to the new function, and the patch is installed. Internally, after kpatch builds the KO file based on the information provided by the kernel, we get a Livepatch containing the relocation section, data, and replacement function. The relocation section records necessary data for relocation, including object names and symbols. The data part contains the patch, the object, and function data. The initial address of the object's KLP object array in the patch part links the patch to the object, and the initial address of the function's KLP function array links to the function part, which applies for function nodes after the Livepatch is inserted to the kernel to enable it. How does the Livepatch manage different functions? Since a Livepatch has many functions, they are managed using a function list. Horizontally, the list shows different functions. For example, as in the picture, function A1, B1, and C1 in the picture. Vertically, it shows the modified versions of each function, such as func A2 and B2. Every time a function is disabled, the function on its upper level is reused to take effect. For example, if function A2 is disabled, A1 will be re-enabled. If A1 is disabled, the original A function will take effect and B1 will move horizontally to become the new A1. Now that we know how a Livepatch works, let's explore patch implementation. To register, enable, disable, and unregister a Livepatch, there are 4 APIs. Each API involves different operations. First, after the KO file is inserted into the kernel applies module initiation to identify functions that need to be run and registers the module's initialization routine. Then the KLP register patch function further processes the patch file. It registers the patch to the KLP patches list, performs symbol relocation, verifies function length, initializes jump label, and executes the load hook function. After the KO file is registered, we run the echo1 command to enable it. Here, the parameter is generated automatically according to the KO file. With the data provided in the patch file, the KLP enable patch function enables the KO file by stopping the machine to perform the kprobes and stack check and modify instructions. The purpose of the kprobes check is to ensure the original function was not modified by the kprobes tool, as overlapping modification may suspend the kernel. Similarly, the purpose of checking the Livepatch stack is to ensure the function is not executed when code is modified. The stack check is performed in the stop machine function before the Livepatch is enabled or disabled. If the check is not performed and modification instructions are executed, the system jumps to an unknown area and crashes. After the checks are done, instructions can be modified. That is, areas at the beginning of the old function can be changed into a jump instruction which links to the new function in the KO file. To do this, we should first check whether any Livepatch has been installed for the function in the Livepatch function queue. If not, back up the original instructions to be replaced and horizontally add the old function to the function list for management. If the function has been patched before, add the Livepatch vertically to the function list. Next, generate a jump instruction and replace the beginning part of the original function with the jump instruction. This completes the Livepatch installation. Similarly, to disable and enable the Livepatch, we need to find the Livepatch in the Livepatch function queue. If only one Livepatch has been installed for the function, obtain the old instructions backed up before. If multiple Livepatches have been installed, obtain the function address of the previous Livepatch and generate a jump instruction. Next, replace the first few instructions of the original function with what we got. If the patch is no longer needed, we can also run the remove mode command to uninstall it. That concludes the main operations involved in Livepatch implementation: inserting, enabling, disabling, and uninstalling. In addition, we use the cat command to query the Livepatch status. Here, the commands used during Livepatch installation can be concluded as shown on the slide. Noticeably, these configurations must be set to Y if we are going to use the Livepatch. The Livepatch stack configuration is optional. If it is set to Y, we must enable Livepatches according to the order in which we inserted them into the kernel and disable them from the last enabled Livepatch. To build a Livepatch by ourselves, there are two options. that is, to build it by writing the module code or try with the Kpatch tool. To use the Kpatch, we need to download the Kpatch source code from GitHub, run the make command in the Kpatch directory to compile the Kpatch tool, prepare a patch to modify the original function, export no profiling calls to 1 to avoid errors, set the corresponding arc and cross-compile. Run the Kpatch build command in the Kpatch build directory. This concludes today's course. You can find the openEuler kernel repository on Git and join our community discussions by submitting an issue or use the Bugzilla platform. Or you can send us an email if you have any questions. We hope you find it enlightening. Remember to follow us on our socials. We'll see you again in the next openEuler mini course. Thank you for watching.